So in lesson 2-2, Roy is still in New York. But now he wants to do both. He wants to eat meals and he wants to go buy tickets. And so they give us this table right here. I'm on page 21. They give us this table and they want us to determine if these options are feasible, if he wants to do both. And I copied the definition of feasible. It means that it is possible for a given situation. And the given situation is, and I got the info from page 17 that the tickets cost $100 and that he spends $40 on a meal. So that's where I got $100 for each ticket and $40 for each meal. So if that's what he's going to spend, okay, then what's six tickets? He wants to go to 6 performances and he wants to eat 16 meals. What's that going to cost him? Well, you guys know that you have to say 6 times 100. And then right here, you have to say 16 times 40. And when you do that, you get 600 here, you get 640 there. You add those two numbers together and you get $1,240. Does he have enough money to do that? Remember how much money he has, $1,360. So if he buys 6 tickets and eats 16 times, he's going to spend $1,240. Can he do that? The answer is yes, it is feasible. And here, the rationale, they want a rationale is an explanation. Why? Is how do we know it's feasible? Because $1,240, they want a mathematical rationale, is less than $1,360. And it's okay to not spend all the money. He has enough money. So now let's do this one. We do, he wants to go to 8 shows. So that would be what, $800. And then 14 meals times 40. I believe that's $560. So you add 800 and 560 and you'll get a total of $1,360. Okay. Is that feasible? He has $1,360 to spend. Remember, that's left over. That's from when we first started the problem. He won that much money. He won, I think, $3,000. Then he paid for his flight and he paid for his hotel. And this is how much money he had left to spend on things. So if he goes to 8 productions and he eats 14 meals, he's going to spend 1,360. Is that okay? Yes, because as long as he's not spending any of his own money, he's happy. So 1360 is equal to 1360. So being less than is okay. Being equal to is okay. Is the way that we can combine those together? Yes, of course. We can say less than or equal to is okay. All right. So less than or equal to is okay. So the amount of money that he spends, the money that he spends has to be less than or equal to $1,360. That's what we're determining. Is this option feasible? 10 tickets, 10 times 100 is going to be 1,000. And then 12 times 40 is going to be 480. You add 1,000 to 480 and you get 1,480. Is this combination of events feasible? Well, the answer is no. And why? Because $1,480 is too much. It's greater than 1,360. And that's not okay. So as long as it's less than or equal to, as long as the money that he spends is less than or equal to 1360, then it's okay. Is this feasible? No. Why am I saying no? I didn't even do any calculations. What does this mean? 14.5. You cannot purchase 14.5 tickets. Now, you could eat 4.5 meals, but you would pay for 5. So you cannot purchase 4.5 tickets. So this is not feasible. I don't care how much it costs. The number of tickets that you buy must be an integer, and the number of meals that you eat must be an integer. Okay, so that's gonna get us through this part. Now, problem number 3 says, can you write a linear inequality that represents ordered pairs TM that are feasible options for Roy? Now, I love Springboard because they give you great word problems. I think Roy going to New York and spending this money is an excellent word problem. But then they just made it complicated because here they've changed normally our points are X's and Y's. And so what they're telling me here is that when I graph this or when I write this equation, I need to think of my T's, which are tickets, as X values, and my M's, which are the number of meals that I purchase, as Y values. That's what they're telling me right here. So we pretty much have it written right here when we have this equation. The only thing we're going to do is say, how were we spending money? Okay, we know that my equation needs to be less than or equal to $1,360. We understand that, but how this dollar sign that I have right here, this came up with 1,240. Where did that come from? It came from taking the number of tickets that I bought and multiplying it times 100, so $100 for each ticket, and then I added it to $40 for each meal. So my equation right here, this is the equation that I used on each one of these to determine whether or not it was feasible. That combination of tickets and meals were feasible. Now, I do want to mention right here that making tickets be on the x-axis and meals be on the y-axis could actually been done the other way. They decided to put tickets on the x-axis and meals on the y-axis. This is not an independent dependent situation. They depend on each other, but either one of them could be on the x-axis and the y-axis, and that happens sometimes. So how did I know to do that? I didn't. They told me. Okay, that's all there is about that. They told me to do it that way. If Roy buys exactly 2 meals each day, now I think it says in the problem, I think he went for 5 days. I'm pretty sure he went for 5 days. You'll have to go back and check on page 17. But if he buys exactly 2 meals each day, so he's going for 5 days, and he's buying 2 meals each. Then how many meals is that? That's 10 meals. Determine the total number of tickets that he could purchase in 5 days. So we are given the number of meals. So what this is saying is that M is equal to 10. So we take this equation, 100T plus 40, plug in that 10 for the number of meals, and then make sure it stays less than 1,360, and now you have an algebra problem to work. So this becomes 100T plus, and 10 times 40 is 400, less than or equal to 1,360. Subtract 400 from both sides, and you get 100T is equal to 960. I'm going to say minus 400 minus 400. And then divide both sides by 100. And you get the number of tickets is 9.6. Now, can he buy 9.6 tickets? No, you cannot. He can buy 9. 9.6 will make him equal 1,360 exactly, but if he buys 9 tickets, and he buys 10 meals, he will spend 9 tickets would be 900, 10 meals would be 400. He would spend 1,300, that's 900. That would be $1,000. Oh Lord, I'm trying to do mental math. This would be 9 times 100, and that would equal 900. This would be 10 times 40, and that would equal 400. And add those two together, and you get 1,300. So he would spend $1,300 if he did this combination. Okay, and then the last one I'm going to do on this video, it says if Roy buys exactly 1 ticket each day, that's 5 tickets. Find the maximum number of meals. So that means that 5 is equal to T. So I'm going to do 100 times 5 plus 40 times M has got to be less than $1,360. So I have 500, because 100 times 5 is 500, plus 40M is less than or equal to 1,360. Subtract 500 from both sides, and that's going to give me 40M is less than or equal to, I think that's 860. All right, divide both sides by 40. And the number of meals that he can eat if he's purchased 5 tickets is going to be 860 divided by 40 is 21.5. Can he buy 21.5 meals? No, he can buy 21 meals, and he can buy 5 tickets. And if he buys 21 meals, if he buys 21 meals, he has spent $840. And he buys 5 tickets, that's $500. And that'll be $1,340. He'll just almost spend it all. He'll have $20 left. All right, I'm going to stop the video here, and then the next video, we will graph all of this.